Okay, so I'll come back and explain the beginnings, but this is where we're at right now. So we talked about how this is a class, a function, and I'll come back and explain that later. But right now we're focused on this part that says hello world. So what's known as a string, and it's a string of characters, and it's called a string literal because we are saying it's literally, we want you to display what we have right here. This, Kemper, stop. This is never going to change, right? Unless I go in and type in change. It's not going to change like while I'm running the program. It's not going to say like, hey, delete the O. Like, no, it's going to stay the exact same. So that's what we call a string literal, and we denote that with the opening and closing quotation marks.
Wait, if you didn't have the quotation marks, then would it be a variable and you'd have to define that then?
So if we didn't have it, it's kind of not clear what it would be. Because a variable is only one word. And we'll get more into variables later. But yeah, you can pass variables into that. Right now, it would give us an error. It wouldn't know what the heck was going on. Okay. So, the other thing to know about system.out.println is... Actually, we'll get onto that later. Never mind. But the next thing we're going to talk about is we're talking about what is a string. Now we're going to talk about something called escape sequences. So let's say I'm going to get rid of hello world. Okay, I'm going to say, what's some phrase where you would use air quotes? Like, I don't know. Okay, let's just say, oh, he really went to the store. I don't know what that means, but okay. Now, if we try and compile this, you can kind of see because it's turned that black, it is going to get an error, right? It's like, it's saying, wait, do you mean that this is something else and you're supposed to close it here? Like, it doesn't know what's going on. And that's because, right, it reads from left to right, so it's going, okay, open a string. Oh, we hit a apostrophe, or quotation mark, close a string. We don't know what the heck this is, but then we hit this again, it's like open a string, close a string. So at first glance, it's like, okay, so can we not use quotation marks in strings? But no, there is a way to do this, and it's called an escape sequence. So the first step to an escape sequence is to use the escape character, which is I think it's called a forward slash actually, because I think it's
Forward?
I don't know. It's the one that slants from left to right. So so when you do an escape character, which is that, it's basically saying, okay, read the next character, not literally, but with a adapted meaning. Now, for an apostrophe, when you do /apostrophe, that means that don't read this as the end of a string, read this as an actual, like, literal character. Now, other ways to use this is, what if I was like, so what if I wanted the string to end here, and I was like, oh, he went away, and then for some reason I wanted to end that with a slash. I don't know why I'd want to, but let's say, right, you wanted to end that line with a slash. Okay, well that doesn't work, because now all of a sudden it thinks the whole rest of the line is a string, and it leaves out all that stuff. So there's actually, you would do a second one, because now what that's going to do is this escape character is going to escape the escape character. So then it's going to say, no, that's not an escape character, that's actually a literal slash. So that's another way to use it. Some other interesting ways to use it. There is something called /t. /t is going to say, it's not saying, like, T doesn't do anything. If I just put T, it would go, toe, he went away. But what the escape character says is, no, this isn't a T, this is a tab. So when you do /t, it will actually indent. If we compile and run, it will kind of do an indent. The indent's kind of small, but, oh, he went away. The other thing you can do is, oh, he went away, /n, hello. If we compile this and run...
Isn't it a new line?
Yeah, exactly. That's going to be a new line. Now, here, let's pull this up a bit so we can see. Oh, he went away. Hello. So see that kind of, and even the other thing is, see how it kind of added a space right here before hello? If we actually delete that space right there, that would go away. Like, it's fine to have it /n and then immediately into the next thing. You don't need a space between them. So, yeah, that's an escape sequence. Let me just double check that's not any more that I'm forgetting about. These things, it's kind of more like, the /n, new line, you're not going to be using a whole ton. Just because, system.out.println, at the end of it, it actually makes its own line. So usually if you want 2 lines, you'll just do 2 system.printlns. Making a new line is generally not seen as super good kind of coding. Let me just double check this real quick. I'm not missing something. Yeah, okay, so I'm not missing anything. So, we have something else. This is our second kind of, not function, but, I mean, it is a function. See, like, println is a function. We have another function that we're going to learn right now. It's called system.out.print. And it functions the exact same way, essentially, like, for typing it in, as println. Let's say, hello. Now, if we run this, it kind of looks like we expect, right? Oh, he went away, hello, and then it prints another line, hello. Now let's add one more, system.out.print. And maybe this time we say world. And we want it to be like, hello, world, on a line below it. We compile. And then oh yeah, and don't forget the semicolons at each line. So we run that, and oh, okay, look at this. It says, oh, he went away, hello world, one thing. So the difference with print is that it does not print a new line. It prints wherever the cursor is. Now, here's an interesting function of print line. People think, right, like if we go, okay, so let's cut that out and paste it right here. Whoops. Fix the indenting. Right, people think like, okay, so it's going to print out hello, then it's going to go to a new line and print out, oh, he went away, hello. Let me run that. And no, it's actually not. Because what println does is it prints exactly where the cursor is, and at the end, it goes and hits enter. So print just prints wherever the cursor is, which if that's after a println, sure, that's fine. Right, it's going to print where the cursor was. But then it's not going to hit enter at the end. Now, sure, you could go system.out.print and then be like, haha, /n, right? And that's essentially what a println is. But that's considered bad coding. Generally, you want to stay away from that.
How does it say hello? Like the O and the O-W? I mean, O-H.
Oh, why does it say that?
Mm-hmm.
So, okay, so it goes to the first line. It prints out hello. Right? The cursor's still at the end of hello. There's no space or anything. Then it prints out, oh, he went away, hello. So that's why it just tacks that right onto the end. And then it says, oh, he went away, hello. Then it hits enter and prints out world below it. And even the other thing you can see is this like ending phrase that says like operation complete. That usually starts on the next line, but actually because we hit print, it's just going to start right after world. So, what was the other thing I was going to talk about? So, we know how to print. Let me check the rest of my lesson plan. Oh, yeah. So, if we want to do a blank line, right? Because a lot of times, like, between a paragraph, for example. Now, you could go, like, /n/n, right, and do 2 new lines. That's generally, again, not seen as a super good thing. I'm going to delete this and kind of write out a new system.out.println so we can get a little cleaner. System.out. Oh, whoops. dot println, and we'll say first paragraph, close it. Oh yeah, and by the way, I mean, you can use numbers in the strings. That doesn't matter. So first paragraph, right? And then if we were to just go system.out.println second paragraph, and we compile, and we run, that's just going to go first paragraph, second paragraph. To make a line in between them, we can go like this. Right? And we just have a blank string. So it's going to print out, it's going to say, okay, what do I print out? I'm going to print out what's right here. What's right here? Nothing. Okay, so I'm done. I'm going to go down a line. And this is really bad style, because what you've essentially done is you've passed it something that's nothing, right? What's much more, like, it's not a huge deal. Like, no computer's going to, like, be like, I'm freezing because, like, this is too much memory, because it has me, like, it's fine, but for style, rather than passing something that's empty, don't pass anything at all, because it'll know what to do. If you don't pass println anything, it'll say, okay, I'm just supposed to print a line. So then I compiled, I hit run, and it's going to do first paragraph and second paragraph. Kemper, yes?
So the difference between like system out print and system out println is println makes a new line, right?
Basically println hits enter once it's done typing whatever it's got.
So what if you did like print and then println? It would end up like the hello and then like the...
Yeah, so if this was print and then this was println and there was, so like if we got rid of this and we just did this as print, and we compile and we run, it's still going to kind of mash them together, because it's just going to print, this is going to continue printing, and then hit enter at the end.
What if you put a space between like the first paragraph and the quotation mark?
Yeah, so if you go like right here and you add a space, yeah, that'll totally work. It'll when you give it a string literal, it'll print out whatever's in there, including spaces, as many as you want. So yes, when you run, then you can have it separate like that, and sometimes that's useful, because like sometimes you want to add spaces into things to make it look nicer. So moving on, we're going to talk about something that's very, very important in programming, and I guarantee you, no matter what programming class you take, and even if you don't take a programming class, you need to practice this because it's so important, is something called commenting. So commenting is where you basically explain what your code is doing. And that's super important because when you're working with other people, right, a lot of times, like, this is fairly easy to see what it's doing, right? It's printing, right? It says print, and it prints text. But when you get to more like complex calculations, stuff like that, it gets really hard to read. So both for yourself and for other people, you do what's called a comment. Now there's two ways. The first is you do a double slash like that. So that's not the same slash as the escape character. That is the other slash.
Backslash.
Yeah, I think it's called a backslash. But so then you do two of those, then you can type whatever you want, and as long as you're on the same line as that, it's going to completely comment it out. When the compiler's reading this and saying, okay, how to turn this into actual code, because I don't know if I've explained that super well, but like that's how the code works. You type this code that you read, but then the Java, something called the compiler will come in, it will read this and say, okay, public class, I need to translate that into something the computer can actually read, which is in binary, which nobody can read binary, so we have a translator to do that for us. Yes, Kemper?
Wait, so you're pretty much... Wait, what does it do? Is it like...
Okay, so yeah, that's where I'm getting to. So when the compiler gets to a comment line like this, it's going to just skip that line. It doesn't care about it. So what you can do is say like, prints out text on one line and then hits enter. You can explain what your code is doing. Now, generally when you're starting out, the code... Whoops. Cancel. The code inside your functions is going to be so simple that you probably don't need one. But what you generally do is you do a comment before your before each function that you have, right? This is defining what main does. And then the other thing you'll usually do is you will usually have a comment up here that defines what your entire program does. Now, for the instant, what our entire program does is basically the same as what main does. And so usually, like when in my class, I don't even have a thing that says what main does, because main is just the program in general. So you would really write that stuff up there. But later on, we'll actually be defining our own functions, so then you need to define those. And kind of explain what they do. Also, like if you type like your name, like Detlef Knaus, period 1, 21, yada, stuff like that. So the other way to write comments, I would recommend this way for writing comments, because it's really easy to read, right? When someone's reading your code, they just go down and they're like, okay, // this is a comment. Next line, // this is a comment. The other way is you do the same slash, and then you do an asterisk. Then, see how it commented and made all of this orange, right? This character doesn't comment the rest of your program, don't worry. What it does is it comments everything until it sees the kind of reverse character. It's the same slash, but just the apostrophe, or the asterisk is on the other side. So then it'll comment out everything in between that, even if it goes over multiple lines. See, it's still commenting out all that stuff. Now, the reason I don't like that is the color helps, but if you were just reading, you're like, okay, this is a comment, right? I don't think people usually are like, yep, this is the character, everything, like, we're not so much like computers. This is easy for a computer, because it reads and it goes, okay, until I see the next character, this is all comment. But for us, it could be a little bit confusing. It's really up to you. I prefer to use the //, but. So that is the other type of commenting you can do. To move on, we're going to go over some super common errors that... Oh, Kemper, would you like some questions?
The slash, like you said, // like, does that make only that line a comment?
Yeah, so the // makes only that line. If I go over here and I hit enter, it's going to go enter and it's not going to know what to do.
Fine.
So, the next thing we're going to go over is errors. So a common error, I'm going to be honest with you, a lot of times the error messages that it's going to give you down there, when you start out, they're going to be really helpful. It's going to say, this line, we don't know what you're talking about here, right? And you can kind of read that, you can see it. That's pretty easy. Later on, it's really not going to be that helpful, because odds are your like mistake is going to be like larger, and so what happens is it'll say like, oh yeah, this thing didn't work right here. So you go and you fix that, and it's like, oh well, yeah, now you have a new thing. This didn't work right here. And it's not that you're creating more errors. It's not realizing how many errors there are. And sometimes, you'll get like 30 errors, and you're like, oh shoot, what did I do? I have like 30 errors. Well, I'm just gonna quit. Like, I can't program. But really, it could be something as simple as you forgot a bracket, or you just forgot to do an escape character, and so you were like escaping all your quotation marks, and it thinks everything is a string. Like, it could be something like as simple as that. So, for now though, one of the easiest ones is, it says something like, when you try and compile it, it says, file name needs to match class name. So that would be if you changed this right here to like, Hell World, and I compiled that, it's going to go, class Hell World. It probably should be declared in a file called hellworld.java. If I change it back, it'll fix itself. The other thing is words are misspelled, right? Because you're typing really fast. Always make sure you go back and check for spelling. The other thing is miscapitalization. That happens to me a lot. Like, I'll be like typing, and then I hold down the shift too long, and I accidentally type two characters that are capitalized at the beginning. That's a big deal in Java, because you need to make sure things are capitalized in the correct places. The other thing, forgetting a semicolon. Even I do this. It's like, you're thinking about the code, you're not thinking about like, okay, now time to end this with a semicolon. Like, no, you're thinking about the code, and so it kind of just slips through the cracks sometimes. The other issues, it'll say forgetting a keyword sometimes. What that means is it's forgetting one of these purple things. Like, if you were just like public void main, it would say you're missing a keyword right here. Actually, it wouldn't. If you forgot to put it in static, I don't think it would. Actually, let's try that out right now. We'll see. It might throw an error. No, so it didn't. So you need to make sure you say static. Oh, whoops. Okay, I guess it wasn't done compiling while I was typing. But, so make sure you have static in there. But like if you forgot public, that would be a game-breaking one. Static is like, if you leave out static, it assumes something else, which is more complex. We'll get into that later. But that's why I was able to remove static, I think, without it blowing up. But make sure you have that in there regardless. Oh yeah, and then not closing a string with quotation marks or forgetting to do the escape character. That's another common one. So yeah, just be on the lookout for those. Now, two things I want to talk about. The next thing we're going to do is we are going to start creating our own functions. Let's check what time it is. It is 3 o'clock, and we are already through basically the entire first chapter. So, congratulations, guys.
How much longer?
An hour.
An hour.
Yes, because it's 2 to 4. Camper stop. Okay, so now we're going to define our own function. So, initially, we're going to do it just... Think of this as like the public static void. Think of it as the magic words, right, that you just call to start your function. So public static void, and then we need to name something. And let's name it like draw diamond, because that's kind of a little like spoiler for you guys. That's what we're going to be doing, kind of to like play around with functions. We're going to say draw diamond, and then just do 2 parentheses. We don't need to put in string args. We can just leave that blank because we don't need any of that functionality. That's something different. We'll get into that later. Just leave it blank. But still, we need to do the open and close ones. Come in and hit tab. Now, something interesting that you'll notice is I did something called camel casing. And it's called that because it looks like it has like humps in the middle, right? Because the capital letter, I start off with a lowercase, but then when I get to the second word, because it has to be one word. You can't put a space in between draw and diamond. It has to be one word to be a function. But to denote that it's kind of 2 separate words, you're not like draw diamond. You have to camel case where you make that capitalized. That is what you do for functions. If it's just one word, you just have it lowercase like this. For classes, you capitalize at the beginning of every single word. And then as we get on into variables and constants, there's different capitalization rules for all of them. Try and pay attention to those, because that makes it really easy later on when you're like, shoot, what is this thing, right? Because it can be confusing. It's like, is that a variable? Is that a function? Knowing the capitalization makes it a lot easier to immediately see that. So we got our public static void draw diamond. So let's get rid of, or I guess for now let's type in our draw diamond. So how I'm going to do a draw diamond is I'm going to do system.out.println, and then I'll do like 1, 2, 3, a slash, and then I'll end that string. And I'm making some mistakes you can probably see pretty clearly. And I'm just going to, print out like each line of the diamond. Right, Kemper?
What does draw diamond mean?
So draw diamond, when you're naming a function, you want to have its name be what it's going to do. Because that makes it really easy when you're like up here, you're like, instead of, I guess I should explain what a function is for. So a function allows you to do 2 things. What we're going to start off with first, what it's first of all doing, is it's allowing you to reuse code. If I wanted to draw 2 diamonds, right, usually I have to go like type in all the system.out.printlns, print out 2 diamonds, and then copy and paste that. And that can get really messy, right? It's probably simple enough for now, but moving on, it's going to get much more complex. So instead of doing the 4 lines of system.out.println to print a diamond, we just type in draw diamond, parentheses, and a semicolon, which I'll show you how to do in a bit.
Oh, I see.
So yeah, so that...
You're drawing a diamond because you're having the slashes?
Yeah, so just give me a second to draw this. This is kind of a weird diamond, but system.out.println, and we'll do the slashes, and we'll do the slashes, and then I'm going to make it turn in now. So we'll do it the other way. And I'm just adding spaces in between here to kind of orient it. Yeah, to put it in the right position. Print lin. This is taking a little bit, but we are almost done. one more line. System out println. Okay, now we are done with draw diamond. So I'm like, hey, this is pretty good. I've done a good job. I am going to hit compile. And I am going to get so many errors. 14, 15, 16, 17, 18. Or, sorry, 6 errors, I guess. It said Java 18, but 6 errors, right? Yeah, because that's a lot of errors. I'm like, okay, I'm going to stop coding. Who can, like, see the error right here? Emma?
You didn't close it with a bracket at the end?
I didn't. Actually, I did close it with a bracket if we scroll down here. So I'm closing it with a bracket. That's not the issue. You might look at the coloring of the stuff to help see. Anyone else see the error?
The semicolons at the end.
The semicolons are where they should be.
Oh, but they're included.
Yeah.
Escape slash.
Yeah, that's exactly it. It's the escape. This quotation mark right here should be ending the string, but it's not because it's being escape charactered. Because I was trying to draw this, but it was escaping that and causing the rest of it to be a string. So, does anyone remember how to make it actually print out literally that? Yeah. So we go down, we hit the slash, and it's going to look kind of weird. The other thing to remember is, oh, we also need them over here. Because actually, even though there's no escape function for slash space, right? It's still going to say like, whoa, I don't know, like this is an undefined escape sequence. So we still need, even though there's no like quotation mark that we'd be commenting or that we'd be escaping, we still need to put in the double slash to make sure that it knows that we're not trying to escape something. So then it's going to look kind of weird.
You need to finish.
Sorry. Oh, what's it?
Don't you need to do it for like everyone, not just like 2, 2, 2, 2? Like,
no, the other sides, those are other slashes. Those are the forward slashes. Or the back slashes. So those don't do anything. So yeah. The other thing to know is like if I do a slash slash right here, that's not going to comment out the rest of that line. The slash slash for a comment has to either has to be like not part of a string. Something interesting you can do is you can actually do like a comment right here, and it'll comment the rest of that line, which sometimes can be useful, but usually you want to kind of comment before it, because you need more space usually for comments. But sometimes if you want to like explain what a specific thing is doing, like this is printing out the top of the diamond, that could be something you do right there. So now we've got that. We hit compile. Another thing to note, when you hit compile with JGrasp, it's going to save your file, which is something kind of nice. Like, if your computer dies and like, oh no, I didn't save, I'm going to have to start from scratch. Like, no, it's been saving as you compile. Then we hit run, and it's not going to do anything. And the reason why it's not going to do anything is because we've defined this function. We've said, when I say draw diamond, do this. But we never said draw diamond, right? It's not going to read through and like start at main and be like, okay, this is empty, move on to the next one. It doesn't do that. It runs main till main is done, and then it's like, okay, program's done. Like, chop chop, program's over. Yes, Kemper?
So like when you're making the diamond and everything, you know how you put the extra forward slash in?
Yeah.
Does it matter if you put it on the inside, the extra forward slash, or the outside?
No, it doesn't matter. It's going to, I mean, you'll see when we print it out in a second, but it's going to count, even though it's 2 characters right there, it's going to count it as 1. So you don't need to worry about, it's not going to like leave an empty space between those or something like that. This will print out exactly how we had it before. So the thing we need to do, tab in, we go draw diamond, type in a name, and then we do the close parentheses, which are empty, because again, it's empty down here. And then we hit it with a semicolon. Now, we have a function. What we'd usually do is we do like a slash slash comment. We say like, draw diamond draws a diamond in the console, or like something like that. You'd explain what it is, just so that you know you're like, draw a diamond, what does that do? It would explain right there. So now, if we hit compile, and then we hit run, it is going to, let me expand this. it is going to print out our little diamond right there. So yay, we did it. We did our first diamond. Now, let's imagine. Now I'm thinking, or let me check what I have to talk about next. I want to make sure I don't miss things. Okay, so yeah, there's something I want to talk about called flow of control. So as I said before, public static void main, this is what the behind the scenes stuff calls. And this is the only thing the behind the scenes stuff calls. This is the only freebie you get, right? You don't have to like code the entire length of Java to get it to, call this one function. It's going to do that for you. Now, what you can do, though, is inside of a function, you can call other functions. So that's how you get to use functions in Java. Because otherwise, you'd have to have everything in this one main function. So how flow of control works is if I have, a system.out.println x, right, just to kind of denote that, what it's going to do is it reads down, it reads draw diamond, then what it's going to do is it's going to go, okay, let's go to draw diamond. The other thing to note, it doesn't matter where this whole function right here is located. This could be before a public static void main, after it. It really doesn't matter whatever order. It's just going to go, okay, I need to look for that. Okay, I found it. It runs all of this code inside draw diamond, and then it goes back to here once that function is done and continues. So if we compile, take a second to compile, and run, it is going to do what we expected, right? It prints out the diamond, and then it prints out this little X at the end. So yeah, so that's kind of flow of control. Sometimes it can get a bit complex. I'm going to show you one thing with flow of control that you never, ever want to do. Well, I won't say never, ever, but probably never in this level of Java will we ever be doing this. But there's something called, this is called recursion, actually. You have a function call itself. Now, I think you guys can all see the problem here, right? It's going to reach the end of draw diamond and say, okay, let's run draw diamond again, right? And then it runs that, and then it runs it again, it just keeps on going for an infinite loop. Java has built-in safeguards, because if you had a computer program that did this, there's something called a memory leak. And basically what it's going to do is it's going to keep on filling up your computer's memory until it gets full and your computer's like, oh crap, I don't know what to do, and it crashes. Java will actually say, whoa, this doesn't work. It throws something called an exception, which is not the same thing as an error, but it's going to say, this is dangerous, we need to stop this. See, it's not going to, because nothing is wrong with this code. This code is completely legal. So it's not going to throw an error when we compile. It's going to throw an error. I'm actually debating if I should even run it, because I'm not super confident in my computer, and I'm afraid it might crash. It should be fine on a good computer, and I'm pretty sure it should be fine here. I just don't want to risk it, because I don't want to lose the recording. But if you want to try that out, sure. And it wouldn't deal any damage to your computer. It would just cause it to, if anything, freeze or something like that. But it wouldn't make it combust or something. So next thing. Oh yeah, so methods that call other methods. That's kind of what main does. Methods that call the same method that it is. Bad, don't do that. That's going to crash computers or throw an error, more likely. So now we are going to kind of move into a little bit of a project almost. Not really a project, but kind of like a mini project, right? I want to print out something that is diamond x diamond. So, I mean, we know how to declare functions, right? So let's do public static void draw x. Yes, Kemper?
Me and Mason need help.
No.
We need help with
something in the code. I fixed the diamond.
And then
But
they move this over.
oh yeah, 'cause this way.
Oh. Yeah, that's what you need to do. Sorry.
And then how
Then
And then compile and run. And that should work. Oh, wait, it's had an error. Why is it having an error?
I managed to delete the diamond somehow.
Oh.
Alright, system out, print in.
Print lane.
Oh yeah, thank you.
Public tag void, draw a diamond. Okay, so the one thing you forgot to do is we need to do draw a diamond right there, otherwise it's not gonna run.
Wait, what?
Yeah.
Wait, didn't we already do the void thing?
You know, you've done the void thing, but you need to type it in main right there so it can call it. I'm gonna pause the recording for a second just so I can answer these questions. Okay, it is recording again. So, the error that was made is an extra bracket error, right? So basically what occurred is they had a program, right? And every opening bracket needs to have a closing bracket, right? Now here's the thing. Every single piece of code that we know for now, there are some exceptions, but every piece of code for now should be within this bracket up here and its closing bracket. Now, how do we determine its closing bracket? It's going to be closed at the next closing bracket it finds, right? Now, right here, it's going to say, oh, actually, this isn't a closing bracket, this is an opening bracket. So now we're looking for one more. So then it finds its closing one right here. Now it's like, okay, so we found that closing one. Now we're back to looking for this closing one. It goes down, oh, there's an opening, a closing. Now that's the extra closing one that we needed to close the class, right? So it's like, okay, class is done. But then it keeps on reading, and it's like, what the heck is this stuff, right? It needs to be inside of the class, so make sure, and this is what you guys did, is you had an extra bracket right there. So now let's see if you compile.
We didn't even have any more text.
No, because you did. Public static draw diamond was outside of the class, and it needed to be inside of the class.
Oh, so we had the second one above
so
the draw diamond?
Yeah,
above
it ended,
the diamond?
it ended it right here, and then it was like, what the heck is that? This is some random stuff. So now if we run, it'll print it out. Okay, cool.
Thank you.
Yeah, no problem. So, public static draw X.
Let me do it.
I'm going to use a little computer wizardry known as copy and paste.
You want a wizard hair?
And
Wait, do we need this? Yeah, we need to get it.
with a simple 2 copy and paste. This is what you did too, Emma.
What?
Did you copy and paste that from the...
Oh, no.
No, yeah. Sorry. I probably should have told you that. Yeah, so see, we can easily do that, because it happens to be that it's a diamond is like the same as an X. But yeah, it still works. So now we have draw diamond, draw X. Now what did I say I want to do? I said I wanted to draw diamond, not print X, but actually draw X. And then let's draw another diamond. And assuming I did everything right, the other thing I want to talk about is I am definitely going to make mistakes. I'm going to forget semicolons. If you see any of those mistakes, please point them out. It's just that stuff kind of happens. So let's check. What did our program do? It printed out a diamond, an X, and a diamond. That is great, right? If you went to a programming class and they said, this was actually one of our first kind of projects that we did. It was like, print out, these 3 things, right? This is exactly what they wanted. If you turn that in, the score you would get.
0.
Maybe not a 0. Like in my class, I had like a 5 out of 10, right? And it's like, what? That's exactly what I needed. And the thing is, we need to make sure we're writing code with good style. Now that kind of means, that's like the first component. Do we have good style? Some of our comments are not so great, right? Like this one is just like, okay, yeah, we don't need that. Our comments, we need a comment right here to describe what this does, like draw X, draws an X, whatever. But more importantly than the comments necessarily, we also have another thing, indentation. We have to make sure we have proper indentation. The final thing that is so important is something called redundancy. Redundancy is it's a very nebulous term. As you advance in the class, it's going to mean different things, but it's going to, the definition will be built upon. What's redundant once will always be redundant, but you might find that new things are redundant. So, redundancy, at this point, is going to be 2 lines of code that are exactly the same in 2 different spots. Right, like, right now, we have draw diamond right here, right? We have no way, and we have it, 2 lines below, right? That's, there's no easier way to do something 2 times than to write it 2 times. Like, you can't just be like, yeah, like that wouldn't make any sense, right? There are ways to do that in the future, but for now, that's not redundant. Draw diamond twice, that's fine. Although, here's the thing, if it was like, draw diamond, technically that's redundant, because it's like 2, or no, it's actually, sorry, that's not redundant at all. Never mind. I'm sorry.
Wait, how would you print it twice without writing it twice?
Without writing it twice?
Yeah.
That's something called loops that we're going to talk about,
Oh.
and that's where you can type in one line of code and have it run that line more than once. So that would be how you would do that. We're going to ignore that for now. The more important thing is what lines of code do we have that are exactly the same, right? The lines up there in main were fine. And like these lines, right, they look very similar. It's like an inverse image. I mean, I could see how you would be like, well, that's kind of redundant because it's like the same thing, just like flipped, but there's no easy way to like flip in it because it's text. If you were doing that with an image, like sure, you could flip the image, that would be easy. But for this, it's like those are different lines. That's fine. What is the same though is this and this, right? And it's the same thing with this and this. Those are the exact same 3 lines of code. So that would be considered redundant. Now, what we can do, right, is so far we've been working at, I'd say 1 level, but technically 2 levels of functions, right? The first level would probably be main, right? Like obviously that's the first function we call. Then we go deeper into that, we go into draw diamond and draw x. We can further remove redundancy by going a 3rd level into functions. Because we can take this code that we currently call twice, the exact same, and we can put it into a function to make it so we only have to type that in once, and we can use it multiple times. The other thing I want to talk about with functions is one of the reasons that makes functions really useful is that also it makes it, when you're using code in multiple places, right, you're drawing like 3 diamonds, right? If you drew 3 diamonds and just copy and pasted the code, and you were like, actually, you know what? I want there to be like little stars at the end of the diamond. You'd have to go back and change every single line of code. With a function, you can just change it in that one place, and it'll change it everywhere. So that's another useful application of functions. So I'm going to create some new functions, and I'm going to call this one draw. I want to say like triangle, but you can't really do a triangle. Let's do a caret. Actually, no, you can't do a caret for function names. It's restricted to letters, numbers, underscores, and then like I think like a hashtag maybe or something like that. Keep it to letters and number scores, or letters, numbers, and underscores in general. And actually, no underscores for function names. Sorry, that's something to keep in mind, because you'll be doing the camel casing. So we could be like draw. Let's do draw capital A, because that's like kind of like a triangle like thing. So, oh, what did I forget? Public, static, void, draw A. Again, we don't need anything inside those parentheses, so we can just close that out. And then inside, let's use some copy and paste skills. And we'll just copy that code right in there. Remember to fix your like indentation when you copy and paste, because a lot of times that'll get messed up a bit. But so yeah, there we have it, draw A, right? And then the other part, right, would be like draw V. And again, I forgot, public, static, void, draw V, open and close brackets, and we'll go down here, we'll grab, we will grab the V text, tab, paste, fix our indentation. So now let's go back to our draw diamond. Right, let's delete this stuff. A diamond is composed of drawing an A and then drawing a V. Does that make sense, everyone? Am I moving a bit too fast for anyone? No? Okay.
Yes.
You guys need...
We're still doing
We just did the X because we're savages.
Oh, okay.
I can get rid of
I
You
just
need that, you need that.
enter, right?
Oh yeah, you just enter and go below that, then you can type another. Another good like style thing. Make sure you have a space between the closing bracket and the next function, right here.
Wait, what?
Yeah, just because it's easier to read that way. That's a good. That's a
Oh,
good
you
style.
mean like this, like we did it, or do you mean like another space?
Another space like between that one. So yeah, enter. Yeah, there you go. So that's just a good style thing. The other style thing that I haven't really talked about, it probably won't affect you guys too much, but also you generally don't want a line of code that's longer than 100 characters. Now, an easy way you can tell this, and you actually can't tell it on my computer because it's, or actually in the recording they can. You guys probably can't out here because the TV's cutting it off a bit at the bottom. But if you look at the bottom right corner of JGrasp, it has a thing that says line, and then 18 or whatever, and then it says col. Col stands for column. And so that will tell you what column you're in, how many characters you have. So if it says column 8, it says, or 31 on mine, it means it's 31 characters long. So just something to keep in mind. And I'll show you ways how to make lines of code that might be longer than 100, make it so that they aren't hard to read. Because there's nothing wrong with a line of code that's longer than 100, besides it's hard to read. That's the only problem. So we have draw diamond, which is draw A and then draw V. And then we have draw X, and I actually added those functions kind of in between the other ones. Again, it's fine, order doesn't matter. To draw an X, that would be draw V, and then draw A. And that's going to, you can even kind of see it right here, right? Like the A and the V, if they were meshed together, would make an X. So let's compile this. Hopefully I did everything right. No errors. We will run. So now, oh, whoops, yikes. Tapped on the wrong thing.
Nice.
Yeah, it worked. There you go. So that's kind of, we have now shortened, actually I'm not even sure if we shortened. We might have added some lines of code, because it's this line right here that's just an empty bracket. Right? Our code might be a little bit longer. When you're working with bigger programs, this will definitely make your code shorter. It makes it less to write, easier to fix when you discover an error, right? You don't have to write out all the code and be like, oh shoot, I made an error in 30 places. You just made it in one place, you fix it there. So let's check the time, 3:30. So we actually got some time to move into the next thing that I wanted to talk about. Do we want to take a short 5-minute break? Do people want that? We'll care. Okay, I think we'll just move on. Yeah. Okay, so what I want us to do is to go into this tab called Interactions here at the bottom. Now, Interactions is a kind of useful function. It's completely separate than the code, than your main code. This is for you to test out various lines of code. For example, I could be whoops. Oh, yikes. What we're going to use it for is to compute.
Wait, didn't you accidentally take out a bracket?
Did I accidentally take it? I did accidentally take out a bracket. Yep, there we go. So I added that bracket back in. That bracket back in. There we go. Okay. So you can use it to test out math like this, right? So I guess the important thing to talk about is there are 5 things called operands. And an operand is something like this. An operand is an addition sign, a subtraction sign. For multiplication, we do an asterisk, not an X, it's an asterisk. And then for division, we do a slash. Then there's 2 more. There is, not B and V, it is the percent sign, which we call modulo. I'll talk more about that later. That's something you probably haven't done in math before. It's something that is sometimes useful for programming. And then the final one is actually the equal sign.
What are we talking about?
These are operands, right? These are the different functions you can do.
Oh, multiplication, addition.
Yeah, addition. So,
Wait, which one's the percent?
Percent is called modulo.
Oh.
And it's actually called I think it's called modulus, but then the verb is modulo. People just call it mod. It doesn't really matter. It's a Latin word. Nobody understands what it means.
The equal sign is...
The equal sign is an operand. kind of. I'll get more into that later. But for now, just know that it's technically an operand, but you probably won't think of it as the same thing as the others. So I'm going to hit enter, and that's going to give me an error because I just typed in some random things. Now, let's say we have 5 plus 5 times 20. Right? Order of operations, that computes exactly how you would think it does. And that's because in Java, we have order of operations as well, and it's basically the same as math. The one kind of important difference, or not difference, but like addition to notice, is that the modulo is at the same level as multiplication and division. So that'll just keep that in mind when you're doing that. It's basically the same level of order. Now, additionally, just like in math, we can do parentheses to override order of operations. And that will be 200, and that computes similarly to how we expect it to do in math. So yeah, that's kind of how generally math works in there. Now here's the thing. If I were to copy this right here and paste it into this program up here, it would throw an error. Because you can't just like randomly do math in the middle. How we do math in Java, because that would be useless, right? This will compute fine, but in the interaction thing, it's actually taking an additional step and saying, okay, I'm pretty sure what he means is he wants me to display this. I'm never saying store this value and then display it. But it's saying, okay, I assume that he means that, because that's generally what you use interactions for, to test your math. Yes, Kemper?
Did it, like, solve it, or did you put in the answer?
No, it solved it.
Okay.
And generally, if you put that in your program, it would solve it for you. It would do the math. It might throw an error, because it's like, why would you be wanting me to just do random math, but then not store the answer, not display the answer? Interactions, it does display the answer for you. But so the other thing we have is we have things called variables that I kind of talked about, but now we're going to get into them a little bit more. So ignore the draw diamond stuff for now, because we don't really need variables to draw stuff. But let's go up. Oops. Okay, let's go up here. Yikes. Okay. So we're tabbed in, and I've got some random spaces right there, but it's fine. There are 4 what are called raw data types. Int, which stands for integer, which is a positive or negative number, but only a whole number. There is double. And double is kind of weird because it's got a weird story behind it. Basically, originally what a double was is something called a float. And that stands for a floating point decimal, meaning the decimal point can move between it. That's like a decimal answer. 2.5 is a float. But originally, float had a certain memory capacity, right? So you can't store an unlimited amount of decimals, right? It wouldn't make computer sense, and there were limitations in the memory at the time. So they said float is going to be, only to the X amount of decimals long that it can store. Well, then memory became a lot cheaper, so then they created double, which is double the storage potential as float. So you should always use a double. That's generally what we use. Float is there, but that's why they call it a double. Because it's 2 times of the floating point. The final, or not the final one. Next we have, what is it called? I forget what it's called. Oh yes, this one we don't use too much. It's something called char. It's a character. Something interesting. When you're typing in strings, right, you use quotation marks. Don't use single quotation marks, like apostrophes. For a character, you do. That is a character, a literal character right there with the single apostrophe. We don't do much with characters. And actually, a string, how I told you before it was an object? A string is not one of these raw data types, because a string is actually a group of characters. But people use strings so often, there's some special stuff with them. It functions kind of like a raw data type, but not really. The final thing, I'll get to your question in a second, is called a Boolean. And a Boolean is true or false. So I could do so we won't get into those quite yet. But yeah, that kind of, really the reason to have a Boolean is kind of not necessarily, because you could just do 0 is false, 1 is correct, and then you could do it like that. But it makes it a little bit simpler sometimes to see, okay, this is true, this is false. So that's the 4th data type that we have. Kemper. Question.
Okay, so you know how you did the single quote a single quote. Is that for if like you are like inputting like a?
Don't even worry about characters for right now. That is how you define a character. It can only be one character long, so it's a character. That's how you define it and say this is a character, not just a random A that's floating somewhere in my program. Don't worry about characters. We won't use them. Not for a while. Generally, the only time you really use characters is when you're working with strings and you want to actually go in and look at each character of the string. But for now, we don't want that. So we had all those data types. Now, let's declare a variable. Now, variable declaration goes something like this. First, you type in the type of variable. Int, boolean, double, char, whatever, right? You type that in. Then you type in the name for the variable. Variables are named the exact same way as functions, which you might think, oh, that could be a little bit confusing. You have the parentheses, which kind of helps differentiate them. But so it's camel case, so I can be like, number of jelly beans, right? And so I camel case each word. So then I could just say that, and that's basically saying, okay, in my computer, take a portion of memory, set it to, like, a way you can think about it as a box, right? And so you're saying, okay, create this box, right? And this box should be the right shape or whatever to hold an integer number, right? So that, and then slap a label on the box that says number of jelly beans. So then when I want to access that box, I say I want to go to the number of jelly beans box. The box called number of jelly beans. Right now it's just an empty box. But we can do stuff with it. We can say number of jelly beans equals. We use a single equal sign to assign something. And this is where I was kind of saying it's kind of an operand, but you probably wouldn't think of that. It'll make more sense than an operand later. But for now, it's just equal sign. Makes sense. And then we'll say 5. Right? So then if we were to say system.out.println number of jelly beans. Now notice something really cool right there. First of all, before we've only used system.out.println to print a string. Right? Do you have a question?
Oh wait, you spelled it like, wait, isn't it cap sensitive?
Oh,
You didn't
yeah.
use capitalized.
Yep, you're right. That was a mistake. Okay. So, before we've only used strings. System.out.println, it can totally print numbers as well. Because it's going to, when you pass it the number, it's going to know what you mean. It's not going to be like, whoa, I don't know what to do with this. It'll say, okay, what they probably mean is take this, turn it into a string, and then display it. So it does all that thinking for you. And I'm putting in the variable name into there. I don't need quotation marks because it's not a literal thing. It's a variable. And so I am going to comment out this code. That's another useful use for comments is you can use it to kind of remove code temporarily. Right? Like I wouldn't want to necessarily delete all my code, but I can take it out for a second, and then when I want to put it back in, I just delete the comments.
It could have just been easier by doing like the slash and then star.
It probably could have been, yeah. But yeah, so you can use the slashes, you can use the slash and then asterisk, yeah?
Are we just storing data right now?
So yeah, what we're doing is we're storing data. We're saying, okay, create this box, put the value of 5 in the box. Here's an important thing to remember. When we say number of jelly beans equals 5, that's not like in math. When you say like x equals 5 in math, that means x always equals 5, right? This is not that. Like we could say number of jelly beans equals 5, and then we could say number of jelly beans equals 6, right? In math, that would be totally incorrect. It's like it can't be both of those numbers. But here, it's totally fine. Because we're just storing a value in a box. Think of it like that, not necessarily like establishing a connection between those two. And then we print out the number of jelly beans. Oh, okay, so then hit end interactions and continue. Number of jelly beans. Oh, I forgot a S right there. So we'll fix the S, hit the compile button, and run, and it's going to print out 6. Now, why didn't it print out 5? It's because I put 5 in there, but then later I replaced it with 6. It can only store one thing inside of that box. So if I say it equals 6, I'm like, okay, throw the 5 out, put the 6 in. Now, an easier way to do this, rather than doing 2 lines of code right here, into number of jelly beans and then number of jelly beans equals 5, you can actually do it all in one step. You can do int number of jelly beans equals 5. Like that. And that's usually how you declare things, because usually when you define a variable, you want to put something in it immediately. Sometimes you don't. Sometimes you want it to use later. But if you want to put something in it immediately, put it in like that. And then if we were to compile and run this, it would print 5. So that's good. The other thing we could talk about is you can create, like, if I were to create another int, and I'm not going to do this because we're running a bit low on time. I could create an int called number of gummy bears, right? And if I say I can say number of jelly beans equals number of gummy bears. I can even say int number of jelly beans equals number of gummy bears, right? Like, I can, as long as it's been defined before, I can even initialize it like that. It totally works. When you think of a variable, there's not many special rules with variables. Just think of it as basically it's a name that refers to whatever value it has. So it's the same. When you say int number of jelly beans equals number of gummy bears, it reads number of gummy bears and says, okay, number of gummy bears, replace that with the value. So it's fairly simple like that. The other thing I wanted to talk about is something called int rounding. So if I wanted to go like int number of jelly beans equals, because here's the other thing, you can actually do operation. I can do 5 divided by 2. It will evaluate this thing to whatever it is. Now what's 5 divided by 2? 2.5. You're wrong.
Do 1.
Is it not gonna? Okay, it printed. It's 2.
Because it rounds.
Why is it 2? Yes. Exactly.
What's
It
the
round.
question? What's the round up?
Yeah.
Here's the thing with ints, right? An int can only be an integer number, and it always rounds down. It always. That's its default
So
thing.
it can be at 2. It can be 2.9 and it can round down.
It will round down.
Oh.
And here's the reason why. Here's why it makes sense. If I say, whoops, I hit my interactions thing. If I go, int number of jelly beans equals 5 divided by 2. Let's define another thing called like int x, just for the sake of time. Int x equals 5 modulo 2. And then if I go system.out.println x, and I run that, it's going to say 2 and 1. Now at first this makes no sense, right? It's like, okay, that's 3 together, right? So basically, do you guys remember long division? Right? You have it out and you know how you before you, yeah.
Huh, wait, it's like not letting me, when I hit it, it says there's nothing to print. When I put in system out the print.
Number of jelly beans, what is it saying? Oh, no main methods. Okay, so here, hit okay. So you don't have a,
Probably because I've been deleting stuff as I've been
yeah,
going,
you
right?
need the main method still. If it doesn't have a, it needs to say public static void main string args, otherwise it has nothing to run.
Wait. So it's just...
So yeah, just type in public static void main, and then I'd even just put that code into main for now. Or not public dot static, just public static space, just like that thing. Except it says void main, and then parentheses string args, like I have up here on my computer. So, long division, right? You guys all remember that? Before you knew how to, like, there's ways to do long division and go into decimal places. But before we knew how to do that, we'd have a remainder, right? What modulo does is it gives you that remainder, right? Because 2 goes into 5 2 times, right? Because it rounds down. With a remainder of 1. And that's where modulo gives you that. Now, you might think, like, why would this be useful? Honestly, you probably won't use it, but the way you could use it is if you have a number, whoops, I'm going to go down here. If I have a number like, that's probably, the other thing, there is a limit on how large an int can be. So, like, don't type like a whole line of numbers, but it's pretty big. So, like, let's say I have, like, this number right here, right? And I'm like, I want only the last 2 digits of that number, right? Like, let's say this is a, like, library card number, right? And the first 5 digits are all the same for everyone. So I only really care about the last 4. So what I would do is I'd say modulo 3. I'd say the last 3 digits, whatever. Doesn't really matter.
Wait, what? Wait,
So I've done modulo 1000. Now what that's going to do is it's going to try and divide by 10,000 or by 1,000. But then it will return those last 3. Does that make sense? Because like it can't get down to those, it returns those. So you can kind of use it like that. That's kind of a helpful way to use it. Other than that, if you want to do division and get into decimals, what you need to do is you need to store things as a double, right? So that would be like double number of generally means. Now, how do you declare a double? Here's the thing. This right here is an int. 5, just plain old 5 and plain old 2, those are actually ints. Now, see what it did, though? It printed out 2.0. Now, here's what we're doing. We have to think in like terms of a computer, right? So we first start off, we declared this box, right? Now, what are we putting in here? All right, 5 divided by 2. These are 2 integers, right? So I'm saying, okay, 5 divided by 2, that gives me 2, right? But then it's like, okay, so I have the number 2, but I need to store it in a double, and a double has decimal places. So I'm like, okay, so I need to convert it into a double. How it does that is by going 0.0. But it's still rounded down. And the reason why is because this, until it's up here, it's still an int, so it still does the rounding. Now how we could change that is if we go 0.0. As soon as there is a double in a calculation, it will convert ints to doubles. That's what Java does. So if I do 5 divided by 2.0, it's going to give me 2.5, which is what I wanted. Now if I do something like 5 divided by 2 divided by divided by 2.0, right? It's going to read from left to right. So it's going to do 5 divided by 2. But those are integers. It's going to say 2. Then it would be 2 divided by 2. Instead of what I wanted, probably, which would be 2.5 divided by 2. See, so we're going to get 1.0. So that's the thing to remember, is like make sure you go through and you pay attention to what data type you're in at each time. Yes, Kemper?
What's that 122?
Oh, sorry, that's from the this stuff right here.
Oh.
That was an old example. It gets the last 3 digits.
Well, I have another question.
Yes.
What, is this like, are you just showing us how to use the whatchamacallit?
Order of operations and math?
Yeah.
Yeah, so that's basically...
Will we ever use this later in the lessons?
Yes, this is definitely, like, most of what we... Math will come in a bit later, because right now we're kind of working with typing things, right? We're going to be, for the first few, like, lessons, we're going to be working on, like, ASCII art, which is, like, art made out of, like, text. And we're going to be working functions, loops, stuff like that. Later on, this is what programming is. That's what 90% of programming is working with those numbers and getting them to be what you want it to be. So, that is super important. We might not use this so much until a few lessons from now. So we have that, so always keep that in mind. The other thing is, what if I have this as an int, right? It is going to have an error. It's going to say, what incompatible types? Now, the reason why it's going to do this is because Java will convert an integer into a double, but it will not convert a double into an integer for you. Because it's saying, that's probably not what you wanted, right? If you have, like, the number 2.5, and you're like, okay, store that in an int. It's like, but you're going to lose 0.5, right? So it says possible lossy conversion. Like, loss, you're going to lose it. So, if you really do mean that, if it's like, no, I really want to do that, you do this thing called a cast. Parentheses, close, and then you type in whatever you want to cast it to. You can do this with other things, too. It's not just specific to int, but so you do that. But if we run this, it's still going to have the same error. It's like, but we converted it into an int. And that's because it converts whatever's next to it. So if we want it to convert this whole thing into an int, you need to put the whole thing in parentheses of its own, like that. Think of it, it's almost like a unit that you're like multiplying into them to change its unit. And now if we run it, we are going to lose that decimal place and round down, but we do get it stored into an int. Now, some people are like, why would I ever use an integer, right? Because a double can do everything an integer can do, and more. You should use whatever data type is most appropriate. If you're going to be working with decimals, use a double. If you're going to be working with only integers, only use an integer. Again, that's just another good style thing. It's like, yeah, you could use a double for everything. When you get into super huge applications, there could be like memory differences and stuff like that you might want to pay attention to. But for now, it would work, but try and stay good style. So yeah, whenever you have an int and a double that are operating, like if you're dividing an int by a double or a double by an int, it's going to convert it into a double for you, because that's probably what you want. If you didn't want that, right, if you had like a double divided by an int, but you really wanted it to be an int, you could cast that first double as an int and then do the division. That would work. So yeah, the other thing I was talking about, we can store expressions and variables like this. The last thing that I wanted to talk about, and this kind of has to do with math, is if I have, let's go back to the interaction thing. Here's a cool thing about interactions. Whoops. You can actually declare variables here. I can say int x equals 0. And when I hit enter, it's not going to do anything. Because it's like, okay, I've created this box, but you never told me to display this box. If you type in x, it'll tell you what x's value is. So I've declared this variable, right? And I've slapped a name on it. Here is a kind of shortcut. What if I want to increase it by something? Like, this is very helpful in loops, right? I want to increase x by 5 every time I run this line, right? There's actually a shortcut for that. Here's a long way. You could say x equals x plus 1. Yes, in math, this would not be possible, right? But we're just saying, take the old value of x, add 1 to it, store that in x. So that works. Now, this is so common, there is actually a shortcut for it. You say x plus equals 1, and that will turn x into 1. You can even do minus equals 1, and it will subtract 1. You can even do times equal 1, or divided equal 1, and it will do the exact same thing. It'll take the value, divide it by that number. Kemper, yeah?
Wait, so does it only have to be 1, or do you mean like any number?
It can be any number. It can be 5, it can be 4. Now here's the thing about x plus equals 1. That is so common that there's a further shortcut for that. Instead of saying x plus equals 1, x plus plus. And the same thing, see if I do x, that's 2 now. The same thing for subtraction, x minus minus. And it's 1.
Wait.
That doesn't work for division or multiplication, though. Yeah?
So, but like, oh, it's because we plugged in the value of x as 1, and then we did plus plus, so now x is 2 because you plugged in, okay.
Yeah. Because x was already 1 from before, and I was like, add 1.
What if you said x was 2, and then you did x plus plus?
It would be 3.
What?
It just adds 1 to it.
Oh, okay.
Whatever the number is.
I thought it added itself to it.
No, it doesn't add itself. It adds this, the x plus plus or x minus minus, is shortcut for x, add 1 to x, or subtract 1 from
but
x.
So like x plus equals, we can change that number.
X plus
but not
equals
x plus.
can be 5, it can be 10. It's saying add this value to x. That's
Yeah.
a shortcut for that.
But
This is a shortcut for saying add 1 to x, so that's even more common.
Okay.
So the final thing, we're running a little close on time, but the final thing I wanted to talk about is if we go to system.out.println, there's something called string concatenation. And that's where sometimes, like, if we just print out this value right here, who knows what that means, right? Like, it's just like, okay, that's a 4. So what you can do is you can say, like, number of jelly beans, and then we do a plus sign to indicate that we're merging those two things together. And now what it's going to do is it's going to display the text and then add whatever value is in that variable to it.
How long is it going to be?
We are just about done. The one final thing I will say is order of operations also works with strings. Like if I have it like this, right, and I'm like plus number of jelly beans. Because maybe I want the number of jelly beans, I want it to be the number of 2 times jelly beans, right? I want it to be like double number of jelly beans. I can do this, I can do that. And what is it going to display? It's going to display 11, which is definitely not double 1. And the reason why it's doing that is because it's reading from left to right. It's like,
I know. It
Okay.
doubled the 1.
no, what it did is it said, okay, double number of jelly beans. I print that. Then I add this to it, right? I say, okay, convert that into a string, add it to there. Then it goes to the next one and adds that. It didn't know to do a math operation on those and then add them to the string. So if I wanted to do that, what would I do? Parentheses. And then if I hit add and I hit run, now it will do double number of jelly beans. Hi.
You're just wrapping up. I'm sorry.
That was actually the last thing I was going to talk about. So yeah.
Awesome.
And that is the class, guys.
Okay,
Thank you.
Thank you. Yeah, thanks for coming. And
Is it 2 hours every week?
it is Saturdays and Sundays, 2 to 4 p.m. Except for tomorrow, it's gonna be 2 to like 3, because I have like some stuff to do.
Yes.
So we will finish chapter 2 tomorrow. We actually got through 1.5 chapters today. Finish chapter 2 tomorrow. If you can't make it to one of them, I'm posting all the videos on YouTube. I'm gonna have to go back and like
Did you ever
re-record.
unpause it?
I unpaused it, yeah.
Are you sure about that?
Yeah.
Are you sure?
Yes. And in fact, I'm